I have 4 statements here, and I want you to think about which of these statements are true. And the first statement is, an object in motion will slow down unless it is acted on by an unbalanced force in the direction of motion. Interesting. Second statement, an object in motion will maintain its speed and direction forever unless acted on by an unbalanced force. Also very interesting. Third statement, an object at rest will stay at rest unless acted on by an unbalanced force. And then the fourth statement, an object acted on by an unbalanced force will always accelerate in the direction of the unbalanced force. So I'll leave you to think about those statements and figure out which of those statements are actually true. It might be none of them, or it might be all of them, or some combination of them. Now let's try to think about each of these statements. So first of all, an object in motion will slow down unless it is acted on by an unbalanced force in the direction of motion. Well, this, at least on a first cut, kind of seems consistent with our everyday experience. If I'm pushing some furniture across the room, so let's say this is the carpet of my house, and I'm pushing a television set, and let's say it's one of those old school heavy television sets. So I'm pushing a television set. The only way that I can keep it in motion is if I keep pushing on it. So let me draw my force of pushing. My force of pushing. So let's call that right there the force of Sal pushing the television set. So the only way that I can keep my television set moving, it seems like if I keep applying this pushing force on it. And if I were to stop doing that, it seems like it will slow down. So on a first cut everyday experience, this seems like it would actually maybe be true. But it only seems that way because I'm actually not accounting for all of the forces in this situation. There's not just the force of me pushing. There's also the force of friction. There's also the force of friction. So I'll call that. So there is also the force of friction. And if I want to keep this TV moving at a constant velocity, my force of pushing, let me make that the vectors look about the same magnitude, because they need to be the same magnitude. If I want to keep my television set at a constant velocity in the direction that I'm pushing, I have to exactly offset the force of friction. If my force of pushing is less than the force of friction, then the TV set will start to decelerate. If my force of pushing is larger than the force of friction, then my TV set will accelerate. But in this scenario right now, I have an object in motion, but there's actually a balanced force. My pushing is completely balanced by the force of friction. Another scenario, if we were to go into deep space, and I'm not even thinking about air resistance right here, but if we were to go into space, where, especially deep space, no planets around, complete vacuum, if an object is in motion, and there are absolutely no forces, not balanced or otherwise, there are absolutely no forces acting on it, then that object is going to stay in motion. The only way that it might change its direction or decelerate or accelerate is if there is a net force on it. And just going back to this example, the only reason why it'll slow down if I were to stop pushing is because there is a net force on it, the force of friction. And if you want to think about it, it would probably be a minor amount of air resistance. So this actually isn't true. An object in motion does not have to slow down unless it's acted on by an unbalanced force. An object in motion can stay in motion as long as it's being acted on either by a balanced force or a set of forces that balance each other, or no forces at all. So that is not true. An object in motion will maintain its speed and direction forever unless acted on by an unbalanced force. This is true. This is exactly what's happening right over here. In the case of a block moving through space in a vacuum, if there are no forces acting on it, no net forces acting on it, it is not going to change its velocity. Similarly, you could have this situation where you actually have forces acting on it, but they balance each other out. In this situation, as long as I could keep pushing forever and the floor doesn't change and so the friction doesn't change, this thing would keep moving in that direction, theoretically, forever. The only way to change its direction or accelerate it in one direction or another direction would be to have an unbalanced force. So maybe if my force of pushing were larger than the force of friction, or if the force of friction were larger than my force of pushing. So this right over here is absolutely true. Third statement. An object at rest will stay at rest unless acted on by an unbalanced force. And this is actually pretty intuitive, I think, for people. If you just leave something alone, it's just going to stay alone. It's not going to just start spontaneously moving. And so this is true. And it's not just the situation where there's no forces, but it could also be the situation that it's going to stay at rest if there are balanced forces acting on it. And so the only way that you can actually get this thing to come out of that rest position is if you have a net force, an unbalanced force. If let's say that this force right here is I guess any amount larger than this force right over here, if they don't completely balance out. So this, once again, is true. Last statement. An object acted on by an unbalanced force will always accelerate in the direction of the unbalanced force. So if I have an object and there's an unbalanced force, and if we net out all of the forces, let's say the direction is in the forces net out and we get a force acting in this direction. This is actually true. The object will always accelerate if it has an unbalanced force acting on it in that direction. It will accelerate if there's a net force in that direction. And there's another way of thinking about it. If you see an object that is not accelerating, like my TV that's moving at a constant velocity, or this thing that's just traveling through space, if you see something that is not accelerating, that means that there must not be an unbalanced force acting on it. You could have balanced forces acting on it, or you could have no forces on it at all, but you can't have an unbalanced force. If you have an unbalanced force, the thing will be accelerating.